Hello, everyone. Welcome to today's session. So, in today's session, we are going to start chapter Exponents and Powers of class 8th. And before we move to the topic, it's very important to know the importance of this chapter, both from the point of view of your school examination and from the point of view of Olympiad examination, so that accordingly we can frame the strategy or we can prioritize this particular chapter as far as school and board examination is concerned. All right. So if I talk about school examination, the weightage of this particular chapter is around 6 marks. But see, because 8th class examination varies from school to school, so there might be some variation as far as the weightage of this particular chapter is concerned in your school. Some schools might give, let's say, questions of less than 6 marks also from this particular chapter. Some schools might give questions of more than 6 marks from this particular chapter. So there might be some variation. Some schools might give you the questions which are carrying exactly 6 marks from this particular chapter. So you can say from 4 to 7 or 4 to 8. That's a kind of weightage this particular chapter has as far as your school examination is concerned. And if I talk about Olympiad weightage means if I talk about the Olympiads which are conducted at 8th level like SOF, IMO, etc., then the weightage of this chapter is you can expect around 2 to 3 questions from this particular chapter in your IMO examination. And why this chapter is very important? This chapter is quite important because you will see the relevance or you will see the relation of this particular chapter in your senior classes as well. In ninth class you will be using the properties that you are going to study here. In your 10th class you will be using those properties. In your 11th you will be using, like in all the classes, in one or the other way you are going to use the properties that we are going to discuss here. All right. So this chapter is quite important. So make sure that you understand it like in the best possible way, and stop me wherever you feel you haven't understood anything. Stop me there and ask me again. I'll be more than happy to discuss that. Right. So I think we should start. I hope the weightage of this particular chapter for both school examination and Olympiad examination is very clear to all of you. All right, so now we have the topics that we are going to cover in today's session, guys. The first is introduction, like what is exponent or what is the relation of this particular chapter in our real life? Do we have any application of this chapter in our real life, or are we just reading it for the sake of reading? That will be our first thing. Then we will have the first topic of this particular chapter, that is powers with the negative exponent. So that will be one of the, you can say, topic of this particular chapter. We will discuss this topic. We will discuss what is the meaning of this. We will discuss what's the application of this particular chapter, this particular topic. So that also we are going to do. Apart from that, the third one is laws of exponent. It's super important. Okay. So this topic that you have here, which is laws of exponent, this is very, very important, I would say. Make sure that you understand it better. And we will be doing a good number of problems as well from this particular topic, which is laws of exponent. To understand it better, to understand the application of the rules or the laws that we are going to study in today's session. All right. So before we actually move into the theoretical portion or the mathematical part of this particular chapter, it's very important for us to understand what is the relevance of this particular chapter in your real life. Do we have any practical application of this particular chapter in our real life? Yes, we do have like many application of this chapter in our real life. And here I'll be taking one of the example to give you an idea of how this particular chapter is applicable in your real life. For example, I hope you all can see this figure on the right hand side, bottom right. Okay. So we are given bacteria exponential growth. Okay. We all know what bacteria is. We studied that in biology. Okay. Now, if you read it, what does it say? Once bacteria and mold starts growing on food, then it is that is not refrigerated, it reaches harmful level very quickly. So what happens is, let's say you bought bread at your home. Okay, you bought bread at your home, maybe bread or maybe let's say chapati, okay, that is there at your home, and you left that chapati or a piece or the slice of bread unrefrigerated, without refrigeration, you left it for some days, okay, what is going to happen in that situation? You will see bacteria or the molds growing over it, and you will see that these they increase in number very fast. Okay, means let's say in on a particular day you are seeing a very small amount of bacteria on it, then on the next day you will see that they will multiply super fast, like they are going to multiply or they are going to increase very rapidly. So this rapid expansion, rapid increase in the number of the bacteria or the mold that is there on bread or chapati or any other stuff, okay, that shows the exponential growth or exponential increase in the number of these, okay. Exponential means which increases very fast. For example, you can see here they have illustrated it using this histogram. Using this bar graph, you have like this in 1 hour, let's say they have given certain number of they are showing here the growth of bacteria over 5 hours at 37 degrees Celsius, and initial population was 100, okay. So what is happening here, like initially it was 100, the bacteria were 100 in number. What happened is after 2 hours they reached 6,000, after 3 hours they reached 50,000, and after 4 hours they reached, like the value became very large, and after 5 hours you can see over 3 million. So this increase in the number of bacteria that is taking place here, this increase in number is called the exponential increase in number. Are you getting this? Just for the sake of an example, just for the sake of an example, let's say there is a chapati that is left or a piece of bread or any other item which is left unrefrigerated for some days, and you see, let's say two bacteria, just I'm taking for an example, you saw two bacteria on that particular piece, okay. You leave it as it is, you don't touch it, and come back very next day after 24 hours and see like what is the increase in the number. Is the increase is the is the increase in the number of bacteria that is slow, or are the number of bacteria they are increasing very rapidly? You will see that the number of bacteria that are there, they will increase very fast, and that increase in the number of bacteria or mold, we say that's an exponential increase, okay. So broadly speaking, there are multiple examples, or there are multiple real life application you will see of this particular topic. And like if you ask me, I find this particular chapter very interesting, challenging also sometimes. But yes, if the concepts are clear to you, you have a good hold over the properties or the laws of exponent that we are going to discuss, and you understand whenever a faculty is trying to teach and make sure that all your doubts are clear, I believe you can easily tackle it. So I hope you all understood what is the meaning of or what is the relevance of this particular chapter in your real life. Understood? All right, so let's move ahead. So we have the first topic here. All right. So exponents and powers. What is the meaning of exponential form? That is very important for us to understand. What's an exponential form? Check out. Okay. Let's say you have a number A. Okay. You have a value A. Okay. And that value is raised to some power. Let us call that power as B. Okay. And I'm going to give it a name. Okay. I'm going to call it X. Okay. Then this form that you have here, this form is called the exponential form. Understood? This form is called exponential form. I will be taking examples also. This form is called exponential form. Now, there are specific names that are given to A, B, and X whenever we are talking about exponential form. This value B that you have, this is called index. Some people call it index, some people call it power, or some people call it exponent. Okay, some people call it exponent. You can call it anything you like to, but generally we call it power. Okay, this value that you have A, this is referred to as base. This is referred to as base or base value, whatever you want to call it. This is this X that you have, This is nothing but that's a value of a raised to the power b. That means when you raised any value a to some power b, you will be getting some answer in that situation. That answer, just for the sake of simplicity, we are calling that particular answer here x. Okay. Now, what is the meaning of this? Let me take an example, guys, to illustrate this in a better way. What's the meaning of this? Let's say a is 2, b is 4. Okay, a is 2 and b is 4. Then what is the exponential form that we are going to have? The exponential form will be y is equal to 2, x is equal to 2 raised to the power 4. I don't know what will be the value of 2 raised to the power 4, but for the sake of simplicity, right now I am calling it x. So x will be 2 raised to the power 4. Now we need to understand what does this exponential form actually says. 2 raised to the power 4 means what? That means we are multiplying this to how many times? We are multiplying this to 4 times. Understood? That means whatever value is written as the base, that value which is written at the base needs to be multiplied the number of times we have the power. Okay. Here the base is a, the power is b. So a raised to the power b means a needs to be multiplied. I'm writing here just for you guys. A needs to be multiplied how many times? A needs to be multiplied b times. Okay. And whatever result you are going to get after multiplying a b times, or in this example which I have taken, after multiplying 2 4 times, that result is called the value of 2 raised to the power 4. Okay, so if I multiplying this 2 into 2 into 2 into 2, that is, if I multiply 2 4 times, I'm bound to get 16. So this form that I got here, 16, which is equals to 2 raised to the power 4, this form is the exponential form, and the result or the answer which I got after evaluating 2 raised to the power 4, that is 16. So that's your answer to this problem which I have taken. Okay. So this form that you have here, this is called exponential form. It should be very clear to see you. Like you can use other symbols also, guys. Like you can say a raised to the power b is equal to c, or x raised to the power y is equal to z. You can use what like whichever symbol you are comfortable with. That does not matter. It's just that you should be very very clear about the different unknowns or the different values that we use to denote here in this exponential form. A represents base, that should be clear. What does b represents? B represent the exponent, you can say power, you can also call it index. What is x? X represent the value of a raised to the power b. And that's exactly what they have written here as well. This 10 that you have here, this has been called base. You can see this 9 that you have here, this is called exponent. And this complete value that you have here, it will be referred to as an exponential form. And that's exactly what is written here in this theory part which is written. Okay, it is a number which indicates the number of times multiplication is to be performed. It is written above the base number on the right side. An exponent can be positive or a negative number. What does that mean? That means this power that you have here, this b, it can be positive, it can be negative, it can be zero also. Okay, so this is the exponent. So they are saying this exponent can be positive or negative, can be positive, it can be negative, or zero. Okay, so there is no restriction as such. Clear? So it's the meaning of exponential form. What's the meaning of exponential form? Second, what is the meaning of base? What is the meaning of exponent? Third, what like this example which I have taken, is that very clear to all of you? You kindly go through it once again. I am giving you 30 seconds. In case you feel you have any doubt, please ask me that. Try it. All right, shall we move ahead? Okay. So now we have powers with negative exponent. Okay. A negative exponent in power for any non-integer is basically a reciprocal. So it's nothing basically. to be frankly speaking. Like it's very easy. What are we trying to say? Here we are talking about negative exponent, or we are talking about negative powers in short. Okay, so let's say you have any value a. Okay, you have any value a. It should be a non-zero integer, of course, right? A, you have any value a, and that is raised to some power b, power minus b, sorry. Okay, so if a is raised to the power minus b, then this a raised to the power minus b can also be written as 1 upon a raised to the power b, or you can also write it as 1 upon a whole raised to the power b, because when you raise 1 to any power, that do not makes any difference. So you can include 1 also here when you are writing whole power b. And here it is very important to mention that your a should be a non-zero term. Why a should be a non-zero term? Because if a is not your non-zero term, then this value that you have, a raised to the power minus b, you cannot evaluate it, guys. This is going to become a not defined term which cannot be calculated by you. So it's very important to pay attention to this term, that a has to be a non-integral term for this to be true. For example, if you see here, you have 2 by 3 raised to the power 2 by 7 raised to the power minus 3. So if you observe this example, what they are saying, you have 2 by 7 raised to the power minus 3. Okay, so if you want to make this power positive, what you should do is you should take the reciprocal of the term which is there in the base. That's what they have written. Reciprocal of the fraction 2 by 7 is 7 by 2. That means whatever term is written in the base, does not matter whether that term is fraction, whether that term is integer or any other value. You just take the reciprocal of that. And when you take the reciprocal of that, let's say here I am taking the reciprocal of 2 by 7, which is going to give me 7 by 2. What is going to happen as a result? This negative exponent that you have, it is going to become positive exponent. Is that clear? So what do we have here? Here you have negative exponent which is equal to minus of 3. That negative exponent which is equal to minus of 3 is going to become positive exponent. That is, you can write it as 7 by 2 raised to the power 3. And you can evaluate it further if you want to evaluate it. This can be written as 7 raised to the power 3 over 2 raised to the power 3. 7 raised to the power 3 will be 343. 2 raised to the power 3 will be 8. So that is going to be the value. So what are we trying to say here? We are trying to say that whenever you come across exponential form in which you have negative exponent, or you can say in which you have negative power, what you have to do is you like if you want to convert that negative exponent or negative power into positive exponent or positive power, all you have to do is you have to take the reciprocal of the term which is in the base. If you take the reciprocal, the power is going to become positive. That's it. Understood? All right, check out. Now they, what are they saying? Like this is very easy problem. They are saying write 3x raised to the power minus 2 using only positive exponent. Basically, you have to convert this negative power into the positive power anyhow. We just studied this. Okay. So we are provided 3x raised to the power of minus 2. We learned that if you want to make the exponent, or if you want to make power positive, all you have to do is you have to take the reciprocal of what is written in the base. So if I take the reciprocal of it, I will be getting 1 upon 3 x raised to the power 2. Understood? Either you can leave it as it is, or if you want to simplify it more, you can simplify it more. That is going to give you 1 upon 3 square into x square. We know what is 1 upon 3 square. That will be 1 upon 9x square. So that is going to be the power here. So the thing is, or the crux of this thing, the topic that we discuss is that if whenever you are asked to convert negative powers into the positive powers, all you have to do is you have to take the reciprocal of the term which is in the base. If you take the reciprocal of that term which is given in the base, the powers are going to become positive. That's it. All right. Okay, check out. Now what do we have? This is the solution for your reference, guys. What are we provided? We were provided 3x raised to the power minus 2. This can be written as 3x raised to the power minus 2 over 1. And what will be the reciprocal of that? That will be 1 upon 3x raised to the power plus 2. And this can be written as 1 upon 3 raised to the power 2 into x raised to the power 2. And you will have 1 upon 9x square. Understood? There they have like on the right hand side, they have mentioned the property that a upon b raised to the power negative m is going to become b upon a raised to the power positive m. It's just that you need to take the reciprocal of the terms in the base. That's it. Okay. Very important. Very important. Very important. Okay. So basically, we are going to study some important rules of exponent. So I will be taking an example in each case to make it more clear for you guys. Okay. So first rule is, what is the meaning of a raised to the power n? A raised to the power n means we are multiplying this a how many times? You are multiplying this a n times. Okay. N times means whatever the power is actually. Okay. So if I have to take an example, let me take here. Example is, let's say I am provided 2 raised to the power 5. What is the meaning of that? That means I need to multiply this term 2, which is written in the base, how many times? This term 2 that is written in the base, that needs to be multiplied 5 times, because 5 is the power. So this is same as 2 into 2 into 2 into 2 into 2. Okay. And that is nothing but that is going to give you 32. Understood? So whenever you come across situation like this, a raised to the power n, that means the number which is written in the base needs to be multiplied the times the power is. That's it. Okay. Now what is the second rule we have? The second rule is a raised to the power m into a raised to the power n is equal to a raised to the power m plus n. What is the meaning of that? Okay. A raised to the power m into a raised to the power n, that is same as a raised to the power m plus n. See, here it is very important to note that this property number 2 which I wrote just now, this is only applicable when the base is same. If you see here, the base is say a. If you see here, the base is a. Okay, if the base of both the terms, both the exponential terms which are to be multiplied, they are exactly same, all you have to do is you have to add the powers. Okay, if you observe here, the bases are same, base is a, base is a. So here the power is m, here the power is n. So what you have to do is you just have to add the powers. So this will be same as a raised to the power m plus n. Okay. For example, for example, if they are asking me to, let's say, solve this 3 raised to the power of 4 multiplied by 3 raised to the power 3. Okay. Then there are two ways to do it. Okay. Or either you can solve 3 raised to the power 4 separately. You can solve 3 raised to the power 3 separately. Then multiply both of them. That is the first approach which is in front of you. The second approach is you can use this second law of exponent, which says whenever the base is same, all you have to do is you have to add these powers that you have. So 3 raised to the power 4 multiplied by 3 raised to the power 3 can always be written as 3 raised to the power 4 plus 3. And what is 4 plus 3? That is 7. So this is same as 3 raised to the power 7. So that's how you have to use this particular rule. Is that clear? Now, what is the next rule we have? Next rule is a raised to the power m, that is further raised to the power n, is equals to a raised to the power mn. So third is, if we have, let's say, exponential form a raised to the power m, and we are raising it to one more power, that is n, then this will be same as a raised to the power mn, and this a raised to the power mn will be same as a raised to the power n raised to the power m. So basically, if a is raised to the power m, and whatever answer you are going to get, that is raised to the power n, then that is same as a raised to the power m multiplied to n, which can further be written as a is raised to the power n, that is further raised to the power m. In all the three cases, the result, the answer which you are going to get, that is always going to remain exactly same. All right. So you have Example, let's say I have to calculate 2 raised to the power 3 raised to the power 5. Then all I have to do is I can write it as 2 raised to the power 3 into 5. That will give me 2 raised to the power 15. So that's how you have to use this rule. Basically, you can always multiply the powers. The answer will not change. Okay? The next one is somewhat related to this one only. Let me illustrate. Fourth one. Fourth one is if you have AB raised to the power n. Okay. AB raised to the power n means you have product or multiple of two different terms in the base. Both the product of both the terms is raised to the power like same power. You can observe here you have AB that is raised to the power n. So this can be written as a raised to the power n multiplied by b raised to the power n. Okay, or you can also write it as b raised to the power n into a raised to the power n, as the multiplication of any two numbers is always commutative in nature, so both will be same. For example, if they are asking me to, let's say, calculate xy raised to the power, not xy, xy raised to the power, let's say 5, then I can always write it as x raised to the power 5 into y raised to the power 5. Understood? What's the next one? Next one is quotient rule. All right, this is again super easy. Fifth one, it says if you have, let's say, two terms in divisible form or division form, quotient form in the base, and both are raised to the same power. For example, here, if you observe very carefully, you have a upon b that is raised to the power n. All right. So what you can do here, you can write it as a raised to the power n upon b raised to the power n. Okay. That means you can always separate the powers with the numerator and denominator. The answer which you will be getting after calculating a upon b whole raised to the power n, and by after calculating a raised to the power n divided by b raised to the power n, both are going to give you the exact same answer or exact same value. For example, let's say if I have to calculate 2 by 3 raised to the power 4. Okay, then what can be done? I can calculate 2 raised to the power 4 separately, 3 raised to the power 4 separately. 2 raised to the power 4 is 16, 3 raised to the power 4 is 81. So that is going to be the answer. Understood? The next we have is a raised to the power m by a raised to the power n is equals to this. All right. If you observe property number 5 and property number 6, which we are going to discuss now, you will see there is a minor change. What is that change? In property number 5, the base was different. Like you were having a in the numerator, b in the denominator, right? So these two values were different. But if we talk about the sixth property, the base in numerator and denominator is same. Okay, but the powers are different. In property 5, base were different, powers were same. Okay, so they are saying if you have this a raised to the power m upon a raised to the power n, then you can always write it as a raised to the power m minus n. Okay, because when you move this a raised to the power n in the numerator, this is going to become negative. Okay, what I am trying to say is, check out here. If you move this a raised to the power n in the numerator, you will get a raised to the power minus n. And because base is same here, then as per property number second, you can add the power. So what will you get? You will get a raised to the power m minus n. All right. Example is multiple examples you have. Let's say you have to calculate 2 raised to the power 4 upon 2 raised to the power 2. So you can write it as 2 raised to the power 4 minus 2. You just have to subtract the power which is in denominator from the power which is in numerator. You will be getting 2 raised to the power 2, which is nothing but 4. All right. And then last one is actually that's an extension of this only. Like if you move this a raised to the power m in the denominator, then you will be getting 1 upon a raised to the power n into a raised to the power minus m. So that can be written as 1 upon a raised to the power n minus m. Like that, both are actually related only. Understood? So these properties which are written here or which are mentioned here, they should be very, very clear to you. I feel in this very first lecture, this is the most important thing that is there. The rest of the things are still very easy. So please go through it, note it, and then we will move to the application of these properties. All right, done. Okay. So here we have the application. What does it says? It says we have to find the value when this 10 raised to the power minus 5 is divided by 10 raised to the power minus 3. So it's very easy, right? I'm going to call, let's say, one of the value as x. So let x is 10 raised to the power minus 5 and y is 10 raised to the power minus 3. Then what do I have to calculate? I have to calculate what is the answer when this x is divided by y. That's what I have to do. So x is divided by y. So what will I have? I will have 10 raised to the power minus 5. That is divided by 10 raised to the power minus 3, right? Now we know the rules of exponent, right? We studied this particular rule that a raised to the power m upon a raised to the power n, that can be written as 1 upon a raised to the power n minus m, because here n is greater, minus 3 is greater than minus 5, so I will try to move minus 5 in the denominator. So if I use this particular rule, I can write it like this: 1 upon 10 raised to the power 5 into 10 raised to the power minus of 3, or this can be written as 1 upon 10 raised to the power 5 minus 3. So I will be having 1 upon 10 raised to the power 2. Clear? So 1 upon 10 raised to the power 2 is going to give me 1 upon 100. So 1 upon 100 is going to be the answer in this situation. Basically, there is one very minor thing which you have to keep in mind, frankly speaking. And that thing is, whenever you are moving any term from numerator to denominator, or whenever you are moving any term from denominator to numerator, the sign of the power changes. That is the only thing which you have to keep in mind. Rest of the calculation is very trivial. So please go through it. Ask me if you have any query. Okay, done. All right. So you can see this is for your reference, guys. It says 10 raised to the power minus 5 being divided by this. They moved this power in the numerator, which is they moved this term 10 raised to the power 3 in the numerator. It became positive. So you will have 10 raised to the power minus 5 plus 3, which is 10 raised to the power minus 2. And if you move 10 raised to the power minus 2 to the denominator, what will you get? You will get 1 upon 10 raised to the power 2, which is nothing but 1 upon 100. That's it. Yeah. Okay. Now we have one more interesting problem here. What does it says? It says if 5 raised to the power 2x plus 1 is divided by 25 and the answer which you are getting is 125. I repeat, if 5 raised to the power 2x plus 1 when divided by 25, the answer you are getting is 125, then what is the value of x, or for what value of x this equation which is given to you is going to hold true? So let's see. What we have 5 raised to the power 2x plus 1. Okay, that is divided by 25. That's equals to 125. See, I'm telling you one important note here. Like whenever you come across situations like this, what you should do is you should try to make the basis of all the terms same. Okay, try to make base of all the terms of all the terms same. Okay, so we already have here 5 raised to the power 2x plus 1. So we are not going to do anything here. But if I talk about 25, you can always write 25 as 5 raised to the power something, isn't it? Because when 5 is raised to the power 2, you get 25. So this is 5 raised to the power 2. And 125, if you prime factorize it, you will see that when 5 is raised to the power 3, you get 125. So you can replace this 125 by 5 raised to the power 3. Okay. Now here, I can use this rule of exponent, yes or no, that a raised to the power m by a raised to the power n, that is going to give me a raised to the power m minus n. If I use this rule of exponent, then this can be written as 5 raised to the power 2x plus 1 minus 2, and this will be equals to 5 raised to the power 3, correct? Here, if you simplify the numerator power, you will be getting 5 raised to the power 2x minus 1, that is equal to 5 raised to the power 3. Now, this situation or this condition which we got here, this is going to be true when this power, that is 2x minus 1, is same as 3. So to solve it further, what we can do is we can equate the powers. So if I equate the powers, you can check here. If I equate the powers, what will I get? I will get 2x minus 1 is equal to 3. So now we can transpose this 1 to the right hand side, and when you transpose this 1 to the right hand side, it is going to become positive. So you will be getting 2x is equal to 3 plus 1. That means you have 2x is equal to 4. And if 2x is equal to 4, x is 4 by 2. And if x is 4 by 2, that means the value of x is 2. So what does it mean? It means that the value of x must be equal to 2 for this particular equation that we have here to hold true. All right. And which property did we use here? We use this rule of exponent, which says that when you have when you have this kind of form, a raised to the power m by a raised to the power n, you can always write it as a raised to the power m by m minus n. So kindly go through this problem, this solution, giving you 30 seconds. Ask me if you have any query, guys. All right, done. Okay, so you can see here they have also done it in the similar way. You are given 5 raised to the power 2x plus 1 divided by 25 is 125. So this 25 can be written as 5 square. 125 can be written as 5 cube. They use the exact same rule which we used, that is a raised to the power m divided by a raised to the power n gives you a raised to the power m minus n. So if we use that rule, then it can be written as 5 raised to the power 2x plus 1 minus 2, which is equals to 5 raised to the power 3. You will be getting 2x minus 1 is equal to 3, and thereafter solving it, you will be getting x is equals to 2, which is going to be the answer here, or the value of x must be equal to 2 here for this situation to be true. Clear? Okay, good question. So this is problem 2. They are asking us what is the value of this 5 raised to the power minus 3, 5 raised to the power minus 2, 5 raised to the power minus 1 plus 5 raised to the power 0. Okay. So which property should we use here, guys? See, if you observe the first three terms which are given in this problem, first three terms have negative powers, correct or not? First term is 5 raised to the power minus 3, second is 5 raised to the power minus 2, third is 5 raised to the power minus 1, and the fourth is 5 raised to the power 0. So I think if we can make the powers here positive, it is going to make things quite easy for us. So the property which we are going to use here is this one, that says a raised to the power minus n, that can be written as 1 upon a raised to the power n. Or in other words, if you take the reciprocal of the base that is given to you, the power is going to convert into the positive value. So what are we provided here? We are provided 5 raised to the power minus 3 plus 5 raised to the power minus 2 plus 5 raised to the power minus 1 plus 5 raised to the power 0. So this first term that I have, it can be written as 1 upon 5 raised to the power 3. Second term can be written as 1 upon 5 raised to the power 2. Third term can be written as 1 upon 5. And the fourth term is going to become 1. Always remember that a raised to the power 0 is always equal to 1 for all a that is not equal to 0. That means if you are having any non-zero value of a and you are raising that particular value to 0, the answer will always be 1. Means excluding 0 raised to the power 0, if the power is 0, the answer would always be 1. Without hesitation, go for that. Okay. Now what do you have? 1 upon 5 cube. That is going to become 1 upon 125. 1 upon 5 square, that is going to become 1 upon 25. This is 1 upon 5 and that is 1. Okay. So we can write it as 1 by 1. So what is going to be the LCM of the four terms which we have in the denominator? LCM of 125, 25, 5 and 1. So the LCM of these terms that you have, that is 125. LCM of 125, 25, 5 and 1, that is equal to 125, correct? So here you will be getting 125 into 5 is 125. So here you will be getting 1 into 5. 5 into 25 is 125. So you will be getting 1 into 25 and 1 into 125 is 125. So this will give you 1 into 125. Okay. So what do you have here? Here you will have 1 plus 5 plus 25 plus 125 over 125. Okay. That's what you will get. So you will be getting 125 plus 25, which is 150, plus 5, which is 155. 125 plus 25 is 150, plus 5, that's 155, plus 1, that is 156. So you have 156 over 125. That is going to be the answer of this. If you want, you can divide it further to get like to convert or to write it in the more simpler way. Is that clear? So what are the properties we used? We use broadly two properties. One is a raised to the power minus n, which can always be written as 1 upon a raised to the power n. The second is if a is raised to the power 0, the value will always be 1 for all a which is non-zero. That means apart from 0 raised to the power 0, if you come across the situation where the power is 0, without hesitation, you can always write it 1. Clear? Please go through this solution before we move ahead. All right, done. Okay. So you can see they also did it in the exact same way. First, what did they this? They took 5 raised to the power minus 1 common. Okay. From first term, second term, and third term. After taking it common, this is the expression they got. And they have also mentioned that whenever 5 is raised to the power 0, you are bound to get 1. So they replace this 5 raised to the power 0 by 1. They replace this 5 raised to the power 0 by 1. 5 raised to the power minus 2 is 1 upon 5, 1 upon 25. This is 1 upon 5. After the simplification, they got the exact same answer, which is 156 over 125. And that is nothing but 1.248. If you want to simplify it, you can simplify it. That's up to you guys. Okay. Now we have two questions which you have to do as a homework, guys. Okay, like these are the practice problem for you. It says the first problem says if you have this expression, if you have 2 raised to the power 3x minus 1 plus 10, that is divided by 7, and after division what you are getting 6 as the value. Okay, then for what value is this going to be true, or you have to find out the x which is satisfying this equation. The second one is if x is provided to you, which is 5 cube over 5 square, 3 raised to the power 5 upon 2 raised to the power 5 multiplied by 2 raised to the power x divided by 3 raised to the power x, and the value is 0.0578, then what is the value of x, or for what value of x is this going to be true? So you already have multiple rules of exponent now. I would suggest that you try it. In case you feel or you get stuck anywhere, you can always reach out your subject expert for the clarification. So let us quickly go through what we discuss in today's session. In today's session, we discuss what is exponent, what is exponential form, what are the different terms that we have in this exponential form. We also learn how this topic, that is exponents and power, related to our real life. That is one of the important thing. The second thing we learn is like how to deal with the negative powers, or how to deal with the negative exponent, how we can convert it into the positive powers. The third thing we learn is what are the rules of exponent. And apart, like more important than that, we learn how we can use those rules of exponent to make things easy for us, because that's what matters. We did problems based on each of them, and I hope you understood all of them. You can try these two questions. So that's it from this session. Thank you so much for attending. Have a great day. Bye bye.